Palm oil, an ingredient found in nearly half of all consumer products. But how does this versatile oil go from the tree to your pantry?
It all begins here, with the harvest of the fresh fruit bunches, or FFBs. Harvesting is precise. The bunches must be collected at the peak of ripeness, no more than 3 days too early or too late.
A single bunch can weigh up to 30 kilograms, requiring strength and skill to manage.
Once on the ground, the collection process begins almost immediately to prevent enzyme activity from degrading the oil quality.
Mechanization plays a crucial role in maintaining efficiency, speeding the transfer of the fruit from the field to the mill. The collected FFBs are quickly loaded onto trucks, where they will begin their journey to the palm oil mill. Time is of the essence. The quality of the crude palm oil is directly dependent on how quickly the fruit is processed after harvest. Upon arrival, the first critical step is the weighbridge. The weight confirms the yield and determines the payment to the supplier.
Precise documentation ensures accountability and traceability for every batch of fruit that enters the facility.
The harvested fruit is now ready to enter the sterilization process, the first true step in oil extraction.
Sterilization is vital. It halts the lipase enzyme that rapidly breaks down the oil, which creates free fatty acids and lowers the oil's quality.
In addition, the high-temperature steam softens the fruit and makes it easier to separate from the bunch and digest later.
The FFs are blasted with superheated steam, often at temperatures exceeding 140 degrees Celsius, for a duration of up to 90 minutes.
This multi-stage steaming process achieves the complete deactivation of the critical enzymes, while simultaneously conditioning the fruit.
The softened fruit bunches are now ready for the next phase, the physical separation of the fruits from the heavy stalks. The thresher tumbles the bunches violently, causing the individual palm fruits to fall off the stalks through the gaps in the drum.
This separation is crucial. Only the loose fruit contains the oil we need. The empty stalks are sent for recycling or disposal.
The leftover stalks, or EFBs, are often used as a sustainable fertilizer on the plantation or...
Next, the loose fruit enters the digester. Here, the flesh, or mesocarp, is
high heat and mechanical action break down the cell walls of the fruit's mesocarp, effectively releasing the crude palm oil. The resulting hot, oily mash is called digested mash, and it is now ready for the mechanical screw press. The screw press is the heart of the mill, where immense pressure is applied to physically squeeze the crude palm oil from the digested pulp.
The result is crude palm oil, a deep, reddish-orange liquid rich in carotenoids. Mixed at the opposite end, the dry fiber and nuts emerge. This press cake is another valuable byproduct, often used as boiler fuel.
The crude oil, still containing significant impurities, moves to the clarification station, beginning with the removal of large solids.
This initial screening step prevents blockages in the subsequent, more delicate stages of the oil purification process.
The oil is heated and allowed to settle in large clarification tanks. This process, often aided by gravity,
The lighter, purer oil floats to the top, while the heavier water, dirt, and sludge are carefully separated and drawn off from the lower sections.
For a final polish, the pre-clarified oil is often run through high-speed centrifuge to remove any remaining microscopic water and sludge particles.
The result of this intensive purification is high-quality crude palm oil, or CPO, ready for storage and further processing.
a remarkable aspect of the palm oil mill is its self-sufficiency. Byproducts like fiber and shells are...
Within the fibrous material are the palm kernel nuts. These are a secondary, extremely valuable crop that is processed separately. These palm kernels are dried and stored before being sent off for specialized crushing to extract the high-value palm kernel oil, or PKO. The purified crude palm oil is stored in large, insulated tanks, kept at a controlled temperature to prevent routine quality checks are performed on every batch of CPO to verify its free fatty acid, moisture, and impurity content before shipping.
These laboratory tests determine the oil's grade, ensuring that it meets strict international standards for the next stage of the supply chain.
Once verified, the crude palm oil is pumped into dedicated tanker trucks or rail cars for transport to a refinery.
The journey of CPO from the plantation to its final destination is a complex, carefully managed logistical operation.
At the refinery, the CPO undergoes a series of advanced purification and fractionalization steps to make it suitable for a wide range of products.
The crude palm oil is now ready for the complex refining process, beginning with degumming.
Degumming removes phospholipids, gums, and other water-soluble impurities using mild acid treatment, which improves the oil's stability.
Next is the bleaching step, which is primarily a physical process where activated clay is added to adsorb. This filtration removes the bleaching earth and leaves behind a much lighter-colored, more refined oil, preparing it for the deodorization stage.
Deodorization is the last and most intense stage. Here, the oil is subjected to high-temperature vacuum steam distillation.
This extreme process removes trace compounds responsible for the oil's natural color, flavor, and odor.
The output is RBD palm oil, a stable, neutral-flavored, and nearly colorless base oil, ready for use or further modification.
Often, the RBD palm oil is fractionated to separate it into liquid and solid components, giving it specific functional properties.
This process relies on controlled, slow cooling, which allows the higher melting point fractions to solidify into visible crystals.
The solid Stearin and liquid Olein are physically separated, yielding two distinct products that serve different purposes in the food industry.
Palm Stearin is often used in solid fats like margarine and shortening, while palm Olein is a liquid cooking oil, favored for its frying stability.
The refined oil is now packaged for consumer use, ready to be shipped across the globe.
From the tropical plantation to the high-tech refinery, every step ensures the quality and consistency of the final product. Automation streamlines the final stage, ensuring rapid and safe preparation for transport to markets worldwide.
The extensive journey is complete. This versatile ingredient is now ready to play its role in global manufacturing and cuisine.
The work of the day concludes, but the cycle of oil production is constant. The next harvest is already beginning, ensuring a continuous supply chain. The link between field and factory is a constant motion.
Palm oil mills often operate 24 hours a day to process the harvest at its optimal freshness.
The sterilization process continues under the intense heat and pressure.
Separating the thousands of fruits from their bunches is a relentless mechanical step. Each individual fruit is now on its way to the core extraction stage. In the digester, the fruit is mashed and heated, preparing the cell structure for the press. The high-pressure press yields the raw, crude palm oil. The remaining solid biomass is a crucial fuel source for the mill's power.
Gravity and heat are used to separate the oil from the water and sludge.
High-speed centrifugal force ensures the removal of even the smallest impurities. The hard kernel nut holds the separate, specialized palm kernel oil. These kernels are crushed and pressed to yield the valuable palm kernel oil, or PKO.
PKO has a different fatty acid profile and is used primarily in confectionery and cosmetics.
The night's production of crude palm oil awaits its journey to the refinery.
Just like the CPO, the palm kernel oil is rigorously tested for quality.
Low free fatty acid content confirms the rapid and efficient processing of the fruit.
Modern mills employ advanced systems to treat all effluent and wastewater before discharge.
The palm oil mill is a complex, fully integrated system, generating its own power from its own byproducts.
The continuous mechanical action is necessary to extract the maximum yield from the fruit mash.
At the cellular level, heat and pressure liberate the stored triglycerides from the fruit's cell structure. Air separation technology is used to cleanly divide the light fiber from the heavy kernel nuts.
Maintaining a precise storage temperature is vital to prevent oil degradation and crystallization.
The refinery continues its task of transformation through the night.
Miles of pipeline transport the oil between the various purification and refinement stages.
Precise control of temperature, pressure, and flow is required for perfect fractional distillation.
The clay acts as a molecular sponge, physically drawing out color compounds and trace metals from the oil.
Rapid cooling preserves the oil's quality and prevents undesirable side reactions after the intense heat of deodorization.
The final product of the refining process is virtually free of color, odor, and taste.
Fractionation is a highly controlled cooling process, critical for separating the oil's components.
Palm stearin's high melting point makes it ideal for specialized food and non-food applications.
Palm Olein, remaining liquid at room temperature, is a common cooking oil.
Palm kernel oil is often destined for the manufacturing of soaps, detergents, and cosmetics.
Bright. The sheer volume of finished products highlights the scale of global palm oil consumption.
Each unit is secured and prepared for the rigors of international shipping.
From the mill to the market, palm oil products move through the world's major trade routes.
Refining can take place far from the source, near major consumer hubs. Precision piping and control systems ensure the correct flow through the refinery stages. The mild acid facilitates the chemical separation of the phospholipid impurities. The spent clay, now saturated with impurities, is safely collected and disposed of or repurposed. High vacuum is essential in deodorization to allow volatile compounds to boil off at a lower, safer temperature. The refined oil is a stable, pure triglyceride, free of the compounds that degrade shelf life. The filter press ensures complete, clean separation of the solid and liquid fractions. The refined products are now ready for a wide range of industrial and consumer applications. Continuous quality assessment is a fundamental part of the refinery operation.
Refined palm oil is shipped in a variety of sizes, from small bottles to massive industrial containers. The fibrous waste from the bunch is naturally composted, returning nutrients to the soil.
This closed-loop system minimizes waste and supports the sustainability of the plantation.
The hard shells are an excellent, high-energy biomass fuel source. All energy for the mill, including steam for sterilization, is generated on-site. The constant rhythm of planting, growing, and harvesting defines the production cycle.
Maintaining the sharp edge of the harvesting tool is vital for a clean and efficient cut.
The correct window of ripeness is determined by color and the number of naturally shed loose fruits.
Efforts are made to minimize the impact of harvesting on the plantation's soil. Modern mills rely on computerized systems to precisely control the steam injection and pressure cycles. A high heat permanently denatures the lipase enzyme, which is key to preserving oil quality.
Centrifugal force, combined with impact, ensures the rapid stripping of the fruit from the stalk. Final checks ensure maximum yield and minimize oil loss in the waste stream. The digester operates under precise pressure and temperature to soften the pulp without causing excessive oil breakdown.
The solid material leaving the press is a mixture of fiber and the inner palm kernel nuts.
Large decanter centrifuges are used to efficiently separate the CPO from the dense, solid sludge phase.
The separated sludge, containing fine solids and water, is routed for further processing and waste management.
Modern mills capture biogas, methane, from the sludge, further boosting the mill's energy self-sufficiency and reducing emissions. This valuable gas is often fed back to the boiler to supplement the energy needs of the mill. Palm kernel oil undergoes its own dedicated, complex refining and fractionation process.
Palm kernel stearin is a hard, high melting point fat, key for confectionery coatings and specialized cosmetics.
Palm kernel Olein is a very stable liquid fat with a distinct mouthfeel, valued in food preparation.
Automated valve systems precisely manage the separation of the different oil fractions based on their melting points. Refined palm products are transported via road, rail, and sea to reach manufacturing facilities across the globe. Traceability systems log the batch number, origin, and quality data for every shipment.
Centralized control rooms allow engineers to monitor and adjust every parameter of the complex refining process in real time.
The controlled, slow cooling allows for the formation of perfect, stable crystals in the Stearin fraction.
Secure sealing is crucial to prevent oxidation and maintain the oil's long shelf life.
The final shipment marks the end of the factory processing and the start of the final distribution network. Peak harvest season requires the mill to handle a massive, constant flow of fresh fruit.
Keeping the transport and processing areas clean is essential to prevent contamination and maintain hygiene.
The throughput of the mill is measured in metric tons of fresh fruit bunches per hour. Massive pneumatic systems are required to manage the heavy, high-pressure equipment. Achieving uniform heating throughout the dense bunch is crucial for total enzyme deactivation. The stalks are often shredded to create a more manageable material for composting or burning. The digester breaks the fruit pulp down into a uniform, oily mash ready for the press. Press requires immense power to physically squeeze the oil from the fiber and nut mixture. High flow rates necessitate rapid and constant primary filtration to protect downstream equipment.
Automated discharge systems ensure continuous, efficient removal of the separated water and sludge.
The separation of the kernel from its hard shell is a complex, multi-stage process involving cracking and pneumatic sorting.
Air classification is the most efficient way to separate the kernels from the lighter shell fragments.
Clean shells are a high-quality biomass fuel, free from oil and moisture. As one day ends, the stored CPO is ready for the next phase of its transformation.
Safety protocols are paramount in managing the high-volume storage of heated oil.
Advanced equipment verifies the removal of pigments, ensuring the oil meets the required color grade. Digital systems provide complete transparency and traceability for every batch of refined oil.
A high vacuum is applied during bleaching to remove absorbed moisture and volatile impurities.
Regular cleaning of the filter press ensures efficient filtration and continuous operation. This final stage is the ultimate refinement,
ensuring a pure, neutral product. The finished RBD oil is quickly cooled to preserve its quality immediately after deodorization. Gentle agitation during the cooling process controls the size and distribution of the crystals.
The slip melting point test is critical to verify the physical properties of the Stearin fraction for its intended use.
Robotics ensure high-speed, gentle handling of the final product packaging.
Secure palletizing is essential for stable, safe transportation across long distances. The daily cycle of harvest and delivery begins again. GPS tracking monitors the precise location and delivery time of the FFBs to the mill. Remote operation ensures worker safety and efficient, controlled dumping of the heavy fruit bunches.
The fruit is completely enveloped by saturated steam to ensure uniform heat transfer.
The efficient handling of byproducts is a key factor in the mill's economic and environmental performance.
The screw conveyor ensures a constant, measured flow of fruit into the digestion stage.
The CPO is immediately collected and pumped to the clarification and purification area.
Precise metering tracks the exact volume of crude oil produced in real time. The heaviest impurities and water are continuously drawn off the bottom of the clarification tanks.
Shell fragments are effectively removed from the kernels by utilizing the difference in their density and weight. The kernels are often spread and dried to remove residual moisture before long-term storage and crushing.
The self-generated heat from the shells and fiber provides the necessary energy for all processing steps. High-pressure steam is safely transported through insulated pipes to every part of the mill.
The net weight of the CPO is calculated upon arrival to determine the final commercial value.
Computer-controlled dosing ensures the minimal and necessary amount of acid is used for degumming.
Hot water washing removes the water-soluble gums and any residual acid.
High-speed centrifuges are employed to immediately separate the lighter oil from the heavier water phase.
Precise dosing of the bleaching earth is key to minimizing cost and maximizing adsorption efficiency. The oil flows down through multiple trays, maximizing the contact time with the stripping steam.
Maintaining the integrity of the high vacuum system is vital for low-temperature steam distillation.
The stripping steam effectively removes all remaining free fatty acids, ensuring an extremely low FFA final product.
Palm stearin is often cooled and molded into large, solid blocks for bulk industrial use.
This solid fat is a key component in a vast range of products, from industrial lubricants to specialty foods. Palm Olein is stored under controlled conditions to maintain its liquid state and prevent any unwanted crystallization.
The refinery's infrastructure is designed to handle multiple product streams simultaneously. Every pallet undergoes a final, stringent visual inspection before it is authorized for shipment. Careful loading and protection ensure the product maintains its integrity throughout the supply chain.
The delivery of fresh fruit is the lifeblood of the mill's operation. The softened fruit is now ready to be stripped from the bunch in the thresher.
Complete separation of the fruit from the bunch is crucial for maximizing oil extraction efficiency.
Engineering safety features prevent catastrophic damage in the event of a mechanical overload.
Maintaining the CPO at an elevated temperature aids in the natural separation of water and solids.
The sludge is comprised of fine fiber, dirt, and water, all of which must be removed from the oil.
The clean-burning biogas is a highly efficient, renewable fuel source for the mill's operations.
Low moisture content is essential for safe long-term storage of the palm kernels.
Silos provide protected, climate-controlled bulk storage for the valuable palm kernels.
The crude oil is pumped from the tanker into the refinery's initial holding tanks.
Gentle, thorough mixing is required to facilitate the degumming reaction without causing emulsification.
The continuous removal of the filter cake maintains the throughput of the bleaching process.
The high-velocity steam jets provide the energy and stripping power for the final refinement. Vast amounts of cool water are required to rapidly cool the refined oil and condense the stripping steam.
Temperature drop is precisely controlled, often over several hours, to manage crystal formation.
Automated handling ensures the integrity of the solid blocks during bulk packaging.
Industrial drums are securely sealed to prevent contamination and leakage during shipping.
The final product is stored in a clean, temperature-controlled environment before global distribution.
A vast logistical network ensures the timely delivery of palm oil products to every corner of the world.
Sustainable practices ensure the continuous cycle by replacing older trees with new, high-yielding saplings.
Efficient water management is critical for the healthy growth and high yield of the oil palms. The sheer volume of harvested fruit requires continuous and rapid processing capacity.
Human oversight remains a key element in verifying automated systems.
Mechanical efficiency at this stage maximizes the amount of fruit available for oil extraction.
The conical shape of the screw steadily increases the pressure, forcing the oil out through the perforated cage.
Continuous washing prevents the buildup of fine fiber on the mesh, ensuring uninterrupted flow.
Preheating the crude oil optimizes the effectiveness of the degumming and bleaching processes.
Earth is carefully dried before disposal to recover residual oil and minimize handling weight.
The deodorization unit is a complex piece of engineering, managing high temperature and extreme vacuum simultaneously.
Oxidation stability tests predict the oil's shelf life and resistance to rancidity.
The crystallization process is often manually checked to verify the progress of fractionation.
Precise pressure control is required to force the liquid Olein out of the solid Stearin.
Bulk products are carefully covered to prevent contamination during storage and transport. The future of the plantation is secured by a dedicated nursery program that nurtures high-quality stock.
Regular soil analysis informs fertilizer use, optimizing the health and yield of the trees.
Training harvesters in proper ripeness assessment is key to maintaining high CPO quality.
The flow of raw material into the mill is a continuous, carefully metered operation.
Regular cleaning prevents buildup and maintains the smooth, hygienic operation of the sterilizers.
Safety is paramount, with barriers and protocols in place around all high-temperature and moving machinery.
Routine analysis of the press cake ensures the maximum amount of CPO is being extracted. The decanter provides a simultaneous, high-speed separation of the oil and the water/solid phase.
Hydrocyclones use centrifugal force to remove even the finest particles from the water and sludge stream.
Excess biogas that cannot be used by the mill is safely flared, preventing methane release into the atmosphere.
The crushed kernel residue, known as palm kernel expeller, is a valuable animal feed.
PKO is stored in separate, smaller tanks, reflecting its lower volume and specialized value. The peroxide value test is an early indicator of oxidation and oil degradation before refining.
External heat is carefully applied to maintain the oil's high temperature throughout the distillation column.
A constant supply of cool water is crucial for the efficient and safe operation of the refinery's cooling systems.
The condition of the filter cloth is regularly inspected to ensure clean separation of the oil fractions.
The solid stearin is temporarily heated to its melting point for efficient bulk loading into tankers.
Tankers are rigorously cleaned before and after loading to prevent contamination of different product types.
The refined product begins its final leg of the journey, directly to the manufacturer or consumer. Good field practice minimizes waste and maintains a hygienic harvesting environment.
The multi-stage sterilization cycle is precisely timed to achieve optimal softening and enzyme deactivation.
The powerful shredder reduces the large, fibrous stalks into a manageable size for composting or fuel.
Live steam injection is used to maintain the high digestion temperature, aiding the oil release.
NIR analysis provides instant, accurate data on the moisture and oil content of the press cake. Maintaining a stable temperature in the tanks is critical for the gravitational separation of the oil. The fine fiber, a highly calorific fuel, is pneumatically conveyed directly to the mill's boiler.
The separate palm kernel crushing plant extracts the high-value palm kernel oil, PKO. High pressure from the screw press releases the palm kernel oil from the hard kernels.
Palm kernel oil is immediately filtered and prepared for its dedicated refinement process.
Tank levels and flow rates are constantly monitored to ensure continuous, balanced operation.
The adsorbent clay must be kept perfectly dry to maintain its activity and effectiveness. Maintaining the high processing temperature is critical throughout the entire deodorization column.
The very low acid value confirms the successful completion of the deodorization stage.
The formation of the Stearin crystals causes the liquid oil to become opaque.
Pipelines are often heated to maintain the fluidity of the oil, preventing blockages in colder climates.
The final product exhibits the stability and consistency required for the global consumer market.
Precise weighing and labeling ensure accurate inventory and customer invoicing for bulk orders.
Rail transport provides an efficient, high-volume link to distant ports and manufacturing centers.
Despite the high-tech process, the daily labor of thousands begins the entire production chain.
Pre-washing the fruit is sometimes used to remove surface contaminants before sterilization.
The continuous operation of the thresher requires powerful, robust mechanical components.
Routine intervention ensures the continuous, smooth flow of mash into the screw press.
External steam coils maintain the optimal settling temperature without disturbing the oil-water interface.
Measuring the moisture and impurity content is a continuous check on the mill's extraction efficiency.
The collected biogas is stored in large, flexible containers before being fed into the power generation system.
Nuts are precisely cracked to free the inner kernel from the hard shell with minimal damage.
The screw press applies immense pressure to extract the high-value oil from the crushed kernels. High-speed agitation ensures complete contact between the oil and the adsorbent bleaching earth. The vacuum system safely removes and condenses the volatile compounds stripped from the oil.
A final polish filter ensures that no microscopic particulate matter enters the storage tank.
Small samples are taken to monitor the progress of crystal formation and ensure the desired fractionation. Volumetric filling machines ensure that every bottle receives the precise amount of oil.
The solid stearin is stored in temperature-controlled warehouses to maintain its physical integrity.
Refined palm oil will be used as a key ingredient in countless food and consumer products.
Digital sign-off provides a permanent, verifiable record of the product's quality and release status.
The cycle of the oil palm, a continuous loop of harvest, transformation, and refinement, continues.
Every stage is optimized for a clean, efficient separation of the components.
Automatic sensors maintain the mash at the exact required digestion temperature.
Press effectively divides the input mash into its primary products, crude oil and press cake.
The high centrifugal force visually separates the oil and water phases, a testament to density difference.
Precise air pressure is required to efficiently separate the light shells from the heavy kernels.
The solid residue from the kernel crush is a valuable, high-protein component for animal feed.
The separated gums are often further processed or used as a non-food additive. The oil is maintained at an elevated temperature to optimize the clay's adsorption efficiency. Precise calibration of the steam flow ensures the correct stripping action without oil carryover.
Immediate and rapid cooling stabilizes the oil and prepares it for its final storage temperature.
As crystallization progresses, the oil becomes thicker and more viscous, requiring careful agitation.
Palm Olein, the liquid fraction, is the most highly consumed palm oil product.
Rigorously cleaning the lines between products is essential to prevent cross-contamination and maintain quality.
Security seals provide proof of the container's integrity from the refinery to the final destination.
The natural environment that nurtures the oil palm is part of the final product's story.
Despite the industrial scale, every step of the process relies on trained personnel.
Teamwork and collaboration ensure the continuous, optimized operation of the mill.
The natural reddish color is a sign of the oil's high content of natural carotenoid pigments.
The commitment to renewable energy and environmental safety is integrated into the process.
The byproducts of the process are as valuable as the oil itself, maximizing resource utilization.
Rigorous testing and quality assurance define every stage of the refinement process.
The final product consistently meets the highest international standards for quality and purity.
Speed and precision ensure that the product is quickly packaged and protected.
The final quality control sticker authorizes the shipment for distribution worldwide.
The distribution network is the final, essential step in the complex supply chain of palm oil. Precise documentation ensures the right product reaches the right destination on time.
Bulk sea transport is the most common method for moving large volumes of packaged products globally.
From a single fruit bunch in a tropical forest,
a global commodity is born and distributed.
The journey is complete. The result is a versatile, stable ingredient, powering kitchens and industries worldwide.